Cool. So let's look into a couple more things with animated that I think are pretty interesting. So let me define a couple of animated values here. Oops. I'll just use the same kind of, width 100, height 200, background color red. Yeah, that's a bit big. Okay, so as you saw, we triggered the animation from component to mount. So what's kind of interesting is that, well, you know what, I'll show you it and then you'll see what's interesting. Well, let's just do it that way. So I'm gonna make this similarly to opacity with value A. I did that again, let's just do value A. And I'm actually going to use false. So in this press, I'm going to say if this dot state dot animating in, then I will do something. Otherwise, I'll do some other thing. So let's start with the other thing. I'll do animated spring this dot state dot value A to value 1. And we have to start that also. Then I will do animated dot spring this dot state dot value A to value 0 start. And I'll delete this unused style, doesn't really matter. Okay, so if I click this, right, it animates in. You know what, I'm gonna change this to timing so I can make this effect more obvious. And duration, 5,000. Okay, so, by the way, if you press this curly brace thing here, it runs prettier on your code. So it's an easy way to format this stuff in Snack. Okay, so if I click this, right, it starts slowly animating that in. And if I click it again, it does nothing because I didn't actually change the state. So let's do this dot set state at the end of this thing to animating in, not this dot state dot animating in. Okay, so now if I click that, animates in, and then if I click it again, if I click it again, it starts animating out. So what happens if I click it in the middle of the animation? Because this is a common problem with animations. It's like, how do you interrupt them? Because you don't want to just suddenly reset to another state. You want to kind of stay where you were in the animation and kind of just reverse it, go from there to some other value. So it's really nice that animated actually takes care of this for you. So see, as this is fading in, I just pressed it again, and it stayed at its value that it was at there, and is still working as expected. I think this becomes more clear maybe if I use, well, let's do a couple of things again. Let's get rid of this silliness and make it larger. And let's do right? So I could stop it at any point, and it doesn't have any like jerky aspect to the animation. It just starts going in the other direction. So that's kind of nice. You can feel kind of safe just if an animation is happening. You can start another animation on it. It just cancels the existing one that's happening on the value, keeps it at its current value, and then animates it to whatever new value you want. You can also do, so as you can see here, like this is a kind of interesting use of interpolation where I take 0 and 1 and then interpolate it into strings, right? I go from 0 degrees to 90 degrees. Actually, maybe this is even more interesting as rotate X. But whatever. So another thing that we can do with it that's pretty cool is like with pretty much any string. So you can do like RGBA. Let's change this to background color. RGBA of that, and go to and change background color to what we're interpolating. Oh, sorry, I made it 0 instead of 1. Right, and so it's able to animate strings like the color of something. I think that's kind of cool, maybe. Whatever.
Is it able to do that because you're storing the current value, the current interpolated value in state?
Well, actually, it doesn't really matter where the animated value is stored. It's kind of a convention to keep it in state. But unless you actually need to do something that involves like re-rendering to swap out an animated value with something else, which is the only use case I found for that, it's just a convention. In terms of like being able to, I guess, do these interpolations into strings, these are just kind of, there's some, you can check out the implementation, but there's some stuff that's basically looking for like numbers, and then if it finds numbers and the numbers follow some pattern, you can go from 0 to 255, then it applies the same kind of curve for that, and it actually factors in like, you can't have 10.2798 in RGBA, so it's aware of being inside of an RGBA string. It has to be an integer. So yeah, there's some clever tricks like that happen here, and can be fairly useful because these sorts of effects, I guess, are kind of common. You want to fade from one thing to another. All right, so I'll just post this quick example here before I move on to some other cooler stuff. What will this one be? Animating background color. All right. So I created a second animated value here. Let's use that to, what do we want to do with it? Well, there are a few coordination functions that exist in animated. There's something called sequence, there is stagger, and then there's parallel. And so these allow you to basically say, like, given some set of animated actions like spring and timing and whatever, like we've written here, perform these in some kind of order. So we have these two values. We can animate them both in sequence. That's maybe not so interesting. Actually, let's look at the docs so I can show you the APIs. And there's delay as well. Oops. So all of these animated things are very composable, right? You can do like a sequence where one of the things in the sequence is like a parallel animation, and is there's loop as well. So if you want to loop an animation until you stop it, and I can show you how to stop an animation in a moment, that might be useful for things like a loading spinner, which you want to just keep looping, and you don't want to manually say, okay, it's finished, now do something with it. So let's do a staggered animation, and yeah, just see kind of how that works. Oops. So I'm going to get rid of this logic around animating in and whatever. Don't need that. So let's do animated.stagger, animated.timing, set state dot value a to So I'm not really doing too much with this right now. Let's even make this more interesting by going like that. Oh, thanks. And let's bind value B. Let's interpolate that to do something different. Oops, what have I done wrong here? Oh, didn't actually use it. And click me, animated stagger, start this value A, value B. Just change that to 0. What am I? E.map is not a function. Doing something wrong here. Stagger. Oops. Forgot to pass in as an array. Got another error. Undefined is not a function. Evaluating e.map. That's a new one. Sorry? Yeah, there's a default duration on it. Yeah, it looks like it's being set properly. Value B, interpolate. Collaborative debugging here. Let's see what I'm doing wrong here. Sequence. Yeah, it definitely takes an array of animations and starts them. Must be a typo. Animated.stagger. Well, let's do this first and then comment that. Figure out what's going on. Okay, so that works. Now let's try animated.stagger like that. Oh, so it's just giving me undefined is not an object, whatever. Maybe there's a bug with stagger right now. That would be interesting. Let's try sequence. Yeah, I think stagger might have a bug right now because that was not working, but sequence works. So let's do sequence. Oh, actually, you know what? I think I'm not passing in a required argument. No, I don't know what's happening there. Yeah, let's use sequence. So let's pass all these in again. Beautiful. Maybe let's do that. Let's maybe. Sorry? Which prop? Time? Okay. Is that a second argument to stagger? Actually not. Oh, time is the first one, followed by. Good call. Okay. Stagger. Let's see if that works. Yeah, there you go. Okay, so it staggers it, thank you for that correction, by 100 milliseconds between each of the animations. So we could slow that down and do like 500. All right, so you can execute some series of things in sequence. And maybe want to put that back to 0 or something. Cool. Let's save this one. So another thing that's really useful to know with animated is to be able to determine when the animation is completed, right? So we get a object passed into the callback for start, which let's just log it out here, and I'll show you what it is. So we do that. And the object looks like this, finish true or finish false. So if you called stop on it at some point, so we can do that by saying like, can you do it like this actually? I'm not even sure if this works. And then no, that's not a thing. I think it's this dot state dot value. There you go. So if you stop animating any of the values, then it doesn't finish. So if you interrupt this animation in some way, then it returns and says that it was not finished. So whatever use case you might have for that, just so you know. And so this, you'll notice also that these functions that are passed in to stagger, timing, spring, none of these, we don't call start on them. We only call start on the composite animation. And that's because the stagger and sequence and whatever takes care of calling start for you and managing when they complete. And so you could build your own thing like stagger or sequence just based off of knowing when something completes or waiting some amount of milliseconds before calling start on one of the animations and that kind of thing. However, it would be a little bit more complicated to build it if you're going to use this thing called native driver. So I'm going to show you now how animated can potentially be a little bit problematic for performance. And we'll look at how we can get around that using native driver. So let's delete value B. We don't actually, yeah, that would be interesting for this example to do this. So we'll have these, let's make 2 views. Right. Let's put them, you're familiar with this already. Flex direction, row. Let's put that in here. And format this. That's fine. And we're going to similarly animate. Let's just do the same thing on each of them, but value B. We'll do that. Background color B, background color A. And sure. Let's do margin right. There we go. So we're going to animate these two values using the same thing. We'll just do animated timing. Dot state dot value A to value 1 and start it. And let's do that as well for value B. And then click that. Okay, so they both happen at the same time. That's great. Let's set a duration on it to 2 seconds. Good. Maybe we'll make it a little less yellow. Oh, that's gross. That's nice. Sorry, I'm just messing around with, I want it to look nice. That's stupid. Ooh, that's cool. All right, so it goes from green to red. So this looks very smooth. It's working good. You can try it on your phone if you like, if you want to scan this QR code. And I'll show you how it slows down. You don't have to scan it, but I'll give you 30 seconds to do that, starting now. Lots of devices connected. Woo, look at that. I don't know if that works for like live. I could send the QR code on Slack. There you go, right there. All right. So if you press click me, right, it probably looks decent, looks like moderately fast. Oh man, I'm losing everybody. And that is great, right? This is what you want. You want it to be smooth like this. But let's introduce some artificial slowdown. So maybe after you start this animation, you do a set state that re-renders a bunch of things, or some data arrives, and then any number of things could happen in your application that could result in a lot of JavaScript processing. So we will just simulate that. I'll just create this function here called Oh, really? Is that not working? Yeah, whatever. Okay. I think maybe until I change something, it uses the previous saved one. Yeah. I'm just going to make this burn CPU thing, and I'll say like, while So let current date. Well, current date minus start date greater than time ms. Rather less than time ms. New date. And sure, why not? Yeah, that seems right. So let's just start doing that like 500 milliseconds after this. So we'll do burn CPU for 3 seconds. Yep, just sort of did that, right? I mean, maybe a better name for this is block JavaScript thread, right? So let's not make it 3 seconds. Let's make it like 500 milliseconds. So you get like part of the animation there, but like the beginning part doesn't really happen. And just so we can see this over and over, I'm going to do that thing of like is done. Like this. And to value. Ugh. Okay, so wish I could get rid of this thing in the bottom. Oh, wait, I can just scroll. Wow, I'm an idiot. Okay. So it, like, you could see it like pauses partway through. Again, if I put it to 1,000, right, like it just jumps right to the next one. There's no smooth animation at all. What happens if I change this so that for the second one I say use native driver true? Now I press click me. Oh, it crashed. That's cool. What did I do here? Duration. What's it? Why is it flashing? What's going on here? I don't know what's going on here now. Sorry, let me just format this. I don't see the code. There we go. It's done, right? Okay, remove that. I think I did something wrong with this state. No, it's fine. Oh, that happens when devices disconnect or not. Wow, that's really messing it up. Sorry, guys, I'm going to go to a different thing. There we go. Get away. Okay, I don't know why you use native driver as I'm working on here, actually. This is quite silly. Let's change this to opacity, just for certainty. It's quite possible that the native driver doesn't actually support background color, and I've never tried that. I will explain that in a moment. But opacity. Oh my God, I'm getting hammered there. Opacity A. And that's not, oh, I didn't give it even background. Background color, black. Of course, you need to see it. Okay, so you can see it like pause when that happens. In this case, it's just like, yeah, that is a better example there of what's going on. See on the right, which is the value B, it's unaffected by the JavaScript thread blocking. Can be made more clear by extending this, all these numbers. Right? So let's make that even more exaggerated. Okay, so it's just this one line here, use native driver true, that is changing the behavior. And even though the JavaScript thread is entirely blocked, as you can see by the box that's on the left side, the box on the right side continues to animate smoothly. And what's happening here is that this animation is actually being the configuration is being serialized and being sent over to the native side so that the entire animation loop, all of the animation configuration, exists on the native side and executes independent of the JavaScript thread. And this is really useful because it's quite easy to accidentally block the JavaScript thread for 50 milliseconds or something, which would drop a few frames in an animation. But if you use the native driver for it, then you're not impacted by that, and so you get 60 FPS animation still for when you use animated. So this is pretty key to doing animations with React Native. It's possible to not use the native driver and then still get performant animations, but you have to be pretty careful about what you're doing with JavaScript while an animation is happening. James mentioned earlier there's a tool that helps with that called Interaction Manager. So when animated runs, it registers an interaction handle. And so if you try to perform a task and use Interaction Manager as the kind of wrapper for the task, then it will wait until the animation is completed, until the task is actually performed. So that's one way to do it, but it's not entirely practical all the time to be wrapping everything in Interaction Manager. And you also don't want to just like force everything to wait for animations to complete, right? Ideally, you fire the animation, it works performantly, and you just get on with doing other stuff in your application. As you saw, though, there are some caveats to using the native driver. It's still coming along in terms of the implementation. iOS is not quite as far along as Android, and not all properties are supported by it. So this is kind of similar to in the web browser, where if you are going to use animations with CSS and you want it to be hardware accelerated, you need to use transform properties rather than layout properties. So you can't use like top, left, width, height. You have to use transform, translate Y, scale, that kind of thing. The same thing applies here. If you want to use the native driver, you have to use transform properties rather than layout properties. And this is because otherwise it would force everything to go through a layout pass, and that would be prohibitively expensive and kind of defeat the purpose almost of using the native driver to begin with. Because if the layout of something changes, you have to fire some callbacks into the JavaScript side on some occasions to do other operations as a result of the layout changing. You might have to like re-layout text, which is quite expensive, and all these sorts of things. And so, it's just limited to those types of things. But you'd be surprised how far you can get with transforms and other things like opacity and whatnot. Those are often the primary things that you use for animations. So that's pretty much most of like the basic animation stuff. There is another thing I want to show you with, let me just save this, with scroll views, because a really neat thing about the animated library overall is that like you can feed in these values. You don't have to use animated.timing to determine what value an animated value is set to. You can feed that value in from anywhere, right? You could animate something based off of, I don't know, your heartbeat or something like that, like the frequency of your heartbeat that changes and animates an animated value. You can use any input source that you want. It just has to be a number that can be fed into this value. And then you interpolate that and apply that to some style. So a very common thing for this, and probably one of the most common things on mobile, is to use a scroll view as the source of an animated value. And so you might recognize this from a lot of apps where you scroll down and then like a header appears, or you pull up and then it like stretches some image. Yeah, we should take a look at how to do that. Before we do that though, just want you to paste this example in here. Just like take a look at it and play with it a little bit. Maybe try animating some other property. And I just want to just give you like a few minutes to let it sink in, the difference between using the native driver and not. And then in about 5 minutes, I think probably some people will have questions. Not everyone has questions right away. So I'll come up and then you ask me the questions and then I answer them. And then we move on, if that seems reasonable. All right, 5 minutes.